All right, hello everybody. Welcome to Peridio Live. It wouldn't be a live event without all the things possibly going wrong. And we finally made it here. We're excited to be talking today about a demo that we've been putting together. But first, my name's Justin Schneck. I'm a co-founder here at Peridio and Chief Product Officer, and I'm joined today with a good friend Dan Walks. Dan, give us a little introduction for yourself.
My name is Dan Walkus. I'm a I work in the embedded space, have for quite a few years now. I have my own freelance contract consulting business at Trellis Logic, and then I teach part-time at CU Boulder.
Awesome. And you're teaching at CU Boulder. What are you teaching?
I teach a course called Advanced Embedded Software Development, and it's basically kind of an intro to building embedded devices that run Linux. So we cover Buildroot, we cover Yocto, and just kind of go through the basics of interacting with Linux, either from user or from kernel space.
Yeah, that's great. And we've met together, brushing up against your work with the Open Embedded for Tegra team. I know that you do a lot of work over there. That's great. The group over there is really wonderful, and looking forward to making all the progress possible to bring more of the NVIDIA ecosystem in through to Yocto. We have a demo that we've been cooking up together with on a NVIDIA Jetson platform. And what we did was actually last week, it's time flies. We were actually out together at Open Source Summit, and it was a great event. We had a lot of people coming to the booth. Peridio with Avocado showing off the Avocado OS. We ended up having a lot of people attending, taking a look at what we're up to. And today, what we're just going to do is we're going to talk a little bit about that demo that we put together, a little bit about what is Avocado and what it kind of means for the state of embedded programming, where we kind of see the direction going with this too. So. To begin, I guess for those of you who might not be familiar, Avocado is a binary distribution that is made to be able to provide package management, not at runtime, but at build time. And so we are built using Yocto, and we produce binary packages for a variety of different common single board computers, EVKs, things like that nature as well. And all of those targets, so we end up pushing the packages up to hosted repositories so that application developers can use our SDK and download the packages with our package management utilities and install those into creating their own what's called system extensions. And so Avocado lets you create your own distribution, effectively your own OS that's part of your application and your runtime that has just the things that you need in it without having to actually build the world. So we do this currently today. We're building for Qemu for desktop testing, but we're also doing things like the IMX93 Freedom boards. Got one here actually. It's pretty cool. And we're building for the NVIDIA Jetson series, the Orin Nano. We're doing that on an NVMe connected one, so got a big old hard drive on there. And we're also building for Raspberry Pi because everybody's got three, four, five of those in their desk as well. So and today what we're doing in this demo is we're showing off the NVIDIA Jetson stuff, and it's because a lot of this is inspired by bringing AI to the edge, or as we like to say, native AI. And there's a lot of complications that come with the bringing these tools down and doing inference on the edge to be able to create some really compelling use cases. A lot of the stuff can have a lot of dependencies. They might be difficult to build or compile. And frankly, it just might be difficult to be able to leverage within a team because the application development cycle is faster. We want to be able to iterate on models more quickly. We want to be able to iterate on applications more quickly than, often the changes that we end up making to like our OS underneath. And I'm really excited because all of the new processors that we're seeing in the market are shipping these like heterogeneous architectures. They're containing neural accelerators. The NVIDIA stuff really has got a lot of power to it to be able to do a lot of inference on the edge, and a really good story and workflow for being able to transfer some of the machine learning tasks that we get with like computer vision and such down to an edge device. And so we kind of wanted to put together a demo that showed some of the graphic, like vision processing mechanisms, and what it would kind of feel like to be able to iterate on a model using Avocado and also using like hardware in the loop debugging, which is one of the features that we showed off with our SDK at the event as well, right? So generally, this complexity is going to increase as more and more AI comes down. And Dan, I think it would be cool to be able to hear some of your experiences too, and like where you've encountered projects in the wild with your work that you've been doing, and where you've seen people take the NVIDIA stuff and really drive it to some projects on edge compute.
Yeah, sure. I think one of the things you had mentioned that I have some history with the OE4T project, and I have been working on and off with that project for in a few different capacities. Some of them through contract gigs, some of them through full time employment, and then some through contract work, and then some on kind of weekends and free time. And yeah, one of the big focus areas I've had there in the past has been on updates. I've worked on updates with a few different update frameworks and kind of trying to bridge the gap between the update mechanisms that NVIDIA supports and that the part supports, and then how we can kind of tie that into tools that are available for Yocto. So I think when you first approached me, it was kind of through the work that I had done previously with some of the update tools. And I think where where Avocado has kind of a compelling story there is just that update is generally not super easy to do with Tegra. There are some pitfalls definitely, and there are some things you need to figure out. And so, anytime you're talking about how can I iterate faster and how can I have a Yocto based known build workflow that I can make tweaks to quickly from a development perspective, I think that's going to resonate with a lot of the folks that have worked with this part.
Cool, yeah. Yeah. I've seen a lot of the work that was absolutely true that you've been doing, and some really cool projects that you've been up to, and some of the stuff that we see through the community as well, what people are working on and how they're taking advantage of some of this stuff. So, what is our demo today? Let's take a peek at some of this stuff. So, what I have here set up is I've got a camera that's pointing at a monitor, which is why I look nice and grainy, and we have NVIDIA Jetson or a Nano, as I mentioned, running a model through DeepStream. And that model is, in our case, um, not correctly recognizing that I'm a person, right? So this is a PeopleNet, I believe, yeah, Dan, right?
Yeah. Yep.
And so the PeopleNet model that we have here is just it's not tuned properly. We can say, and what we can show is a bit of how we can kind of use hardware in the loop to be able to rapidly iterate on our models and see if we can kind of tune this and put it in place. Um, at first, let's get a little bearings. We can see I've got my model on the left here skitzing out a little bit. And on the right, I've got a terminal window. And in this terminal window, I've just got two tabs open. So the first one here that we're looking at, this is on the Jetson. This is sort of like the terminal output from the Jetson itself. And the second one here, this is our SDK, right? So we can do a little work in here and take a peek. So over on the first part of it, let's take a peek at just what hardware in the loop might look like, even from the binary package management perspective, right? So over here, if I type in which GDB, we'll notice that we don't have GDB installed. And if we wanted to be able to go so far as to install extra packages while the hardware is running, we can do that pretty easily. Over in our container, I can type avocado repo, and in our system extension that we're generating, I'll install GDB, and that's going to query the repository, see that we have GDB ready to install for this target, and that's going to bring the packages down and just install them directly into the sysroot that we're building locally. Now, what we do for hardware in the loop is we mount the sysroot for that we're building for this extension. We mount that using NFS across the network to our running target. And system extensions allow us to be able to make it so we can point at a folder basically and mount and have the system extension functionality extend using that, right? So if I go back to our target here, we can even let's see, system D this X. We can see with the status that we have the Triton demo system extension, and it's including opt-in user in the hierarchy of directories that it's overlaying to. And if I were to systemd sysxt, if I were to refresh my extensions, then from here we should be able to see that now we have GDB installed. And just like that, that's a pretty easy way to be able to approach the first set of functionality. You know, in a traditional approach to building the system, if we didn't have a package installed, we'd enable that in a recipe, and Yocto would end up building that again into a monolithic image that we can then, you know, either try to patch up and piecemeal over, or maybe on SCP if we're trying to feel fast, or you know, we would have to reflash and reburn again, which can be a pretty time-consuming moment, right? All right. Now, one other thing. Let's see for this demo here. Let's pretend, you know, right now we've got some work. If we were to go into the app directory, and we see our Triton Jetson demo folder. In here, we just have a couple scripts and the deep stream example that's running, right? So this is all being mounted in through the system extension. This is in the op folder that's being patched up. And inside of our models, you know, from the NFS, let's say we have, you know, our PeopleNet model. And in our PeopleNet model, we have a couple different versions. Well, you can see here, we obviously clobbered one of them because it makes a compelling demo. But you know, we iterate a little bit, and as a data scientist, it's easy for me to be able to just work with a model on my machine, and I want to see it run on real hardware. So in this case, I'm just going to run one of the scripts that we have that just sets our model up to the new version here. So we can say I'm going to set it up with this new one, and this just basically sets up the model repo files so that we can tell Triton, we're using Triton inference server here, to be able to load this new model, and we want to try out, right? So Triton's pretty cool because it's nice and composable. We can basically set it to reload the models, and without dropping a beat, we can see that now all of a sudden everything's working, right? So if I switch over to some full screen on a remote, we've got, you know, fully functional squares drawing faces, and you know, actually recognizing people properly. This greatly improves the speed of development for data scientists, for application developers, because it provides an experience then where it's very familiar. If you need to be able to install extra packages, you can just do it using package management techniques. If you need to be able to do any file management or even just like pushing models of changes, you can do that very quickly with having your extension mounted in over NFS. And it in ways like really beats some of the alternative slower loop cycles that we would feel with having to rebuild constantly to be able to get those resources into the system and try them out, right? So,
Yeah, and I think the Triton server is a pretty, you know, we were kind of brainstorming what are some things that you could do to show off the capabilities of Avocado, and I think Triton server is a pretty good marriage of, you know, the abilities that that provides, and seeing it being able to reload a model without restarting the pipeline is pretty impressive thing for, you know, someone who's used to working with AI pipelines. That's not usually the way it works. But so yeah, I think that kind of combining those two features together, and I think maybe one other thing we can say is we are just barely scratching the surface of what Triton can do as well. So I think you can make a lot more interesting use cases here where you are like, you know, offloading the inference onto another discrete GPU based server, and you know, combining some of the use cases with the edge and discrete GPU. So
mhm.
yeah, I think there's a long ways you could go from here, but this is kind of a cool way to just demonstrate the technology.
Yeah, absolutely. I think inference servers in general are probably going to become more ubiquitous as we move forward, especially on edge devices that can afford some of the power. You can, like as you mentioned, some of the cool things you can do with Triton. You can do model ensembling, which is nice. You can also it acts as like a network-based client. So if you have many applications that need to perform inference or even compose like inference pipelines, it's nice and pluggable in that way that you can kind of have like a mechanism to like coalesce your inference pipeline across a network connection, like for local applications to kind of share that. It'll also
Yeah.
handle all the yeah the resource sharding as you mentioned. Yeah, I'm excited to be able to see like a distributed cluster that we can like hit up a bunch of these at one time. Um,
Hmm.
but but it just makes things pretty easy and much more approachable when it comes to um, yeah like setting up quick turn pipelines. And as we move forward with Avocado, one of our great desires is that while we offer a mechanism where you can create your own extensions, we want to pre-build some stacks that have great value that traditionally might be difficult or very large and cumbersome to stand up yourself. That you can just reach each easily for same way through the binary package management mechanisms and install into your host while you're building because we can have many extensions participating in the system at any time. That means that then we can offer something like Triton as a system extension that you can just decide, I need that. I want that as part of my system. And, all of the system extensions will layer up in the system as it composes together, right?
Yeah, and I think that this is highlighting a lot of great work that's been done by the OE4T community, especially Matt Madison, and the specifically talking about Triton Server. I think we got a huge amount of help from Elias on this one. Elias Churgi has done some great work here, and yeah, there is a lot. There's plenty of work still left to be done, but the fact that we could pull this demo together on pretty short notice was we're we've had a lot of help. We're standing on the shoulders of giants, as they say.
Yep. And in addition, from Avocado's perspective as well, we are built using Yocto. We truly love and believe in that as a underpinning technology. It's fantastic, when it comes to being able to create distributions. It does have a bit of a steep learning curve as it gets a rep for, right? And
Yeah,
so,
we were talking about the presentation that Frank Vasquez did at OSS, where he had the image of the dude from The Big Lebowski,
yeah,
you know, saying that it was a quote from Reddit, right, where someone was saying if you're building with Yocto, you're entering a world of pain,
yeah.
and I think everybody, especially people who have learned Yocto, and probably most of my students, can probably emphasize with that. I usually try to encourage them that it's worth the effort, and you will see the benefit if you don't see it yet. But I think if you go through the process of like trying to productize and ship something that and I always give NVIDIA great kudos because I think they make a great product for getting something stood up on your desk and getting something running
Mhm.
quickly, and like this demo, the way I started was I just stood up exactly what they deploy with Jetpack on my desk, and I got the demo running fairly quickly from that. But I think scaling from there to hey, let's build 1,000 units is kind of where the challenge comes in, and where Yocto has a lot of features that really makes that much easier to do. And I think after Frank's talk, I got to thinking a lot about the I don't know why exactly this jumped into my head, but I was thinking a lot about I think it was the inauguration speech from JFK, like back in the '60s, where he was talking about going to the moon, and he said we go to the moon not because it is easy, but because it is hard, right? And and I kind of feel like there's almost a little bit of I don't know, maybe masochism or something like that when you're like, well, I could have got it done so much faster by just using the off the shelf NVIDIA distribution, but it ends up kind of being a pay now or pay later scenario. It's like when you're ready to scale, the tools that Yocto provides are great. So this is where I think you know the work that you're doing at Avocado to kind of try to ease the on ramp for folks around this is going to make a lot of sense.
Yeah, uh, composing a system with system extensions affords a great advantage in that if traditionally you'd type 50 apt-get commands to get it into your system into a state that feels nice on the runtime with like Jetpack, reproducing that is difficult in ways where if you've not taken good notes, or even then moving to a production grade as you're mentioning, like pay now, pay later. With system extensions, you get that same feeling, a friendly developer tooling, but you're in a situation where you're ready to be able to ship at any moment. So it's, I think, a great way to get set up for success in that way. So
Yeah.
looking to the future, with this technology, I want to ask a couple questions. Let's see. So, for one, I want to see, as we move forward with Avocado, as we move forward with creating more of these products. To close this out here, I'd like to hear, Dan, like, what are your thoughts for what the next wave of AI-enabled edge devices might kind of be? Like, what things do you see as prevalent domains, like use cases that are out there, that you've had experience with?
That's a great question. I think one of the things that I would like to experience more myself is sort of the LLM piece, and I haven't got a lot of exposure, frankly, to LLM on Jetson yet, and I'd feel like LLM on the edge is probably still in its infancy, but I think that you could come up with some pretty interesting use cases where you're kind of combining some amount of LLM capabilities on the edge with going out to the cloud when you need to, for
Hmm.
the kind of queries that you probably are not going to be able to handle on the edge. So that's one area that I'm interested in. I'm interested in seeing where that goes. I don't have any direct experience over with that over myself, but I think my in terms of my experience and the applications that I've worked on, they've mostly been vision based and vision based with some inference. And I think that I've if you look back at like what's changed since 2017 on that, it's really just that all of it has gotten so much easier to do, that to the point that you can really stand up a pretty functional app really quickly, typically with some Python code that's doing some impressive things that, 6 or 7 years ago, you probably wouldn't have been able to do. So I think that's exciting from the sense of like just enabling people to do uh, video related inference on the edge for a whole bunch of use cases that we probably aren't even thinking about right now.
Yeah, to the great point, I guess, and our goals at Avocado is to make this easier for people to be able to reach for. We don't want to hide Yocto from people. There's always a way to be able to engage with it, and in case you need to do chip down stuff or like even your custom SOM and carriers, that's definitely in our purview. As we move forward, we're going to start to release some more of the features that we showed today, hardware in the loop, further deeper NVIDIA Jetson support. And our goals are just to, yeah, drive forward and make it easier to be able to use. So, stay tuned and looking forward to that stuff. Dan, I know that you've got some drive too. Like, what do you want to drive people for here? What do you want to rally them around?
Yeah, I really like, folks using the NVIDIA platform or people interested in the platform, especially if you've got any interest in the combination of um, the Jetson platform and Yocto, to check us out at OE4T and all the work that's been done there. And I think a pitch that I always give my students too is like just watch the things that are happening there, and you'll learn a lot. So that I've always found that to be true in being associated with that project. And we took a lot of work for this demo that was present in the open source community already, and there's a lot of work related to it that we still need to do, and someone still needs to help with getting that upstreamed and tested and everything like that. So if this demo resonated with you, if you're interested in the technology that went into it, there's going to be a pull request ready for your help, whether it's testing or doing some additional development. And so please find us and join us. We do a monthly call. So we'll have one next week, Friday. Welcome to join that or join our element discussion. There are links to that on our OE4T wiki page.
Great, yeah, and check out more about Avocado at avocadolinux.org, and you can also visit us at peridio.com to be able to learn more about how Avocado fits into a complete end-to-end product development lifecycle for you shipping what you need to ship for native AI. So, thanks everyone for joining us today. I look forward to another one of these, and stay tuned for more. Thank you.
Thanks, Justin.